We'll get started here with lunar news right off the bat. Sadly, this month is mostly stories about how not to get humans to the moon by 2024. The first one is SLS, which is a space launch system, the big rocket that NASA is behind originally. Their test flight is probably going to slip into next year. So they've had a series of schedule delays over the years. That one's not quite so surprising, but the other two are rather surprising, and I'll just jump right to what they are. The first one is spacesuits. The idea is to get humans to the moon by 2024. The Artemis program is doing that. And there has been a program underway really for quite a few years, since 2007, to make some new spacesuits to do that. And it really just comes down to 2 crew suits for the people on the moon and 1 suit for test use at the space station. And then, some prototyping before that. 420 million has been spent. The total program is about $1 billion, and it looks like it's falling behind. There's 27 different organizations involved in building parts for that versus 2 that were used for the space station. Now, what's wrong with what we have? Well, all we have right now are 45-year-old suits that were used in the space station. They're getting rather old. They're kind of restrictive. And the key thing is they're really not designed for long moonwalks. I mean, you don't have gravity at all in the space station. It's a little different kind of situation. And of course, dust is a concern too. And, this is not so much an issue on the space station. Now, SpaceX has some flight suits they use for the Crew Dragon, but that's really short-term protection against fire and, brief interludes in space. But that's not really intended for long duration outside use. Now, the Inspector General, which is a part of NASA, really, kind of an auditing function, they basically said, well, that's it. It turns out it's too late. It's not going to come done in time. We can't get there by 2024. Kind of a bad bureaucratic response. I mean, the correct response should be, oh my gosh, let's fix this. Well, that was what he said. But obviously what's going to happen is NASA is going to make amends on that. They're going to continue the work they have, but they're going to try to award some commercial contracts in 2022 also. Needless to say, Elon Musk had things to say about this, as he always does. Too many cooks in the kitchen, and then he did say that SpaceX could do it if need be. So chances are he'll be a bidder on, whatever contract is coming up soon from NASA. Now, the second thing that came up that was kind of out of the blue, so to speak, is Blue Origin's lawyers. A little background on this for everybody who hasn't been following it closely. The Artemis program basically sets up astronauts in a lunar orbit, and then they have a separate lander to go down to the surface called the Human Landing System, or HLS. And the budget was cut by Congress last year, and NASA ended up awarding a contract to SpaceX by itself for a variant of their Starship program. The original assumption had been there would be 2 contractors to maintain some competition, but there wasn't enough money left, so NASA went with 1. Blue Origin protested. The Government Accountability Office has rejected that protest, and Blue Origin even offered a $2 billion discount off of their price, which was still $1 billion higher than the SpaceX bid. But clearly they wanted to get back in. So now the next step is Blue Origin is actually suing NASA. And as a result, NASA had to halt the work. They had a court agreement that if the court would hear the thing, they would at least wait until November 1st to do any work under the contract. So it's essentially stopped it. And you could say it's kind of analogous to the way that Amazon filed suit against the Pentagon. They had a $10 billion contract out for IT infrastructure called JEDI. And all the rulings were really favoring Microsoft, but the whole thing was still tied up in court so long that finally the Pentagon just gave up. They just said they're not going to do it. And it seems to be what they're trying to do here. Ironically enough, Jeff Bezos, the head of Amazon and Blue Origin, he was back in 2019, he was comparing that time to the Apollo era, saying that, people are just suing the government when they lose, and that's not really right. Well, it turned out that was apparently more of a foreshadowing. We thought it was a complaint, and it turned out it was more foreshadowing. It really is costing a lot of goodwill for the company, which is not a good thing for Blue Origin because they really are just falling farther and farther behind SpaceX. I mean, they haven't, produced anything that can get to orbit yet. They are apparently suffering some brain drain. So this is not really a good look for Blue Origin anyway. Of course, Elon Musk had tweets about that too. he said if lobbying and lawyers could get you to orbit, Bezos would be on Pluto. And he also said that Bezos retired from Amazon basically to pursue a full-time career filing lawsuits. That's not 100% true, but anyway, that's the kind of stuff that's going on. But in it, one way or another, these programs are being delayed, and that does risk the 2024 original plan. Okay, moving on to Mars. Well, the Perseverance rover, that's been there now since summer, and it didn't succeed in getting its first sample. What happened is they drilled it. You can see it in this picture here. They drilled it, and apparently it was pretty powdery. Somehow or other, between drilling it and it up and storing it, it just crumbled away to dust and was lost completely. And this caused a lot of consternation at first. No one could really figure out how it happened because they thought there ought to be something. Now, of course, other theories arose as opposed to just having a dusty rock. I'll leave it to you to decide which is the correct explanation for why that sample disappeared. Meanwhile, they moved the rover to a different location. They looked for more solid rocks. They found this one. They've drilled it, and it appears that they have successfully taken the sample and stowed it away. So where is Perseverance, that rover, right now? And its helicopter. Remember, there's a helicopter that goes with it. So it went on a landing site. It's been moving around, on the surface. It had to go around a a field of sand dunes. They made good use of the helicopter. The helicopter could just fly right over that. And in fact, its pictures were what helped to decide that the rover really couldn't, go over those sand dunes. It was just too risky. They could get stuck. And so they've been making use of the helicopter to scout ahead. That's working out pretty well. Interesting that if you look at the distance driven by the rover now, it's been about 1.3 miles. The distance flown by the helicopter has been 1.66 miles. So they've actually gotten more distance covered out of the helicopter, which is just a very small add-on to the overall rover mission. But we shouldn't forget there are other rovers out there on the surface of Mars. There's two of them. One of them is a Chinese rover, and that's just completed its primary mission, which was 3 months. They've driven about a half a mile and taken samples, done a lot of the same kinds of things that the American rover had done. Then they, of course, will continue as long as they can, but at least they wanted to declare victory, just like we do. Usually after 3 months or so, we say we got everything we wanted, and now it's all gravy, and that's what's happened with them as well. Now, the other end of that is the Curiosity rover. That's been on the surface of Mars for 9 years. It's driven 16 miles, it's gone up 1,000 feet up a mountain. This is a view, it's really taken from a composite picture that they just released recently. It's very dramatic scenery over there because they're going up a mountain. So if you're interested in interesting mountain scenery, you might want to follow the Curiosity rover even more than the Perseverance rover. And of course, they have a map showing the path, but it's probably easier to see what's going on from these views. Now, the landing site for that lander, or that rover, was in a little blue circle right here. It's in an area called the Gale Crater. It's a big crater, and there's a mountain in that, which is kind of unusual. That's a fairly big mountain, about 18,000 feet. And they land there, and the idea was you want to survey for possible evidence of past biological life and just study the geology. So you want to go somewhere where you're way at the bottom, and then you can kind of go up in altitude, and you're seeing different sedimentary layers, different kinds of rocks. So you're seeing a lot of different things, and that's what's happened. So the picture down below shows a view. This was sort of toward the top of the mountain, but they figured out that these hills in the beginning here are basically a form of iron ore. There's some clays here, some sulfates, all kinds of things that they're seeing as they go up. Here they're showing the mission as they've been climbing up the mountain through the various different areas. And right now, they're pretty much at the end of this graph. This graph was made up a few years ago. Now, besides rovers, there's also a lander. The lander is the same thing, except it doesn't move around. It just goes in one place. This particular one was there to study the interior of Mars. So they're using seismic analysis in particular, and of course, just listening to local sounds, and they analyze the magnetic fields. They were hoping to get a lot of information on heat flow, and of course, they track the weather. Now, this lander has been there for almost 3 years now, and some new recent papers came out as a result of some of the observations they've made. That in particular, the center of Mars is molten, but it's a lot there's a lot more there than was thought. The crust is a lot thinner, in other words. Now, they had some failures. The heat probe was supposed to go down 16 feet. They only managed to get 14 inches. It seems like it's just pretty hard to get samples on Mars. The other main problem they face is the panels are obscured about 8% by dust. I mean, this particular device is powered by solar panels, unlike the small nuclear-powered heat sources that are used on the other rovers. It's probably going to force the end of this mission in 2022 because as time goes on, at some point they won't be able to make it through the night when it gets so cold. The batteries won't have enough power to keep things warm. They've tried everything. They've tried various ways of shaking and vibrating things and trying to knock off the dust. They did find that if they use the robot arm to scoop up some of the sand, which is kind of coarse nearby, and just literally drop it on the solar panels, that helped. And that in fact has stretched out the life beyond what they thought they might be able to. But this is getting near the end of its life. Now, one thing, everything on Mars will stop communicating with Earth for a couple of weeks around October 7th. And that includes the rovers, the lander, the satellites around Mars for that matter. It includes the Chinese as well as the American ones. And the reason is simply that Earth and Mars are on the opposite sides of the sun, so you can't really transmit directly. Now, sometime in the future, we'll probably have relay satellites out at Lagrange points, and we'll be able to, see around the sun, but we don't have that right now. Now, this solar conjunction is what it's called. That occurs about every 2 years. So this is just, one part of living in space. There's things you don't really think about when you're on Earth, but, when you're in space, you have to worry about these things. Coming in a little closer to home, around Earth orbit kind of altitudes, let's talk about that. First one is, there were 2 resupply missions to the space station in August, the International Space Station, ISS. One of them was using the SpaceX Cargo Dragon, and the other was using the Northrop Grumman Cygnus, and with their associated rockets. There are some significant differences in these, although obviously they had to meet some of the same specs for docking and so on. But docking is different. With the Dragon, it's fully automated. They just pretty much fly in directly and dock, and human intervention is not required. People obviously watch it, but it's not required. The Cygnus is a little different, and that's what's shown in the picture here. They have to grab the thing with the robot arm. You can see that's the one labeled Canada here because they built the robot arm. They have to grapple it and then pull it in and connect it up. So it's a much more labor-intensive operation, nothing automatic. This is a picture, of course, of that Cygnus spacecraft. And like all of these, what they do is they've all deployed solar panels because they need power from the time that they're launched into orbit to the time they finally dock. There's some other differences. Reuse. These the cargo dragons from SpaceX, they're reusable 5 times, and in between they splash down, and they have parachutes and they splash down into the ocean. Whereas the Cygnus, it just basically is thrown away and burns up in the atmosphere. So the payloads are different as well. The payload is rated as higher on the cargo dragon, although it hasn't really been tested yet. The highest delivery load ever delivered so far was in fact on the Cygnus. Earlier this year they took up 8,400 pounds, and that's the maximum that's been demonstrated so far. But the big difference is on the return. You can return things from the space station, or from low Earth orbit, back down to Earth. They call that down mass. And of course, because the Cygnus is disposable, basically all they can do is fill it up with trash, and just it gets burned up in the atmosphere along with the spacecraft itself. Now, this is significant if you think about it. Down mass is really the key. If you're going to have any kind of space manufacturing, I mean, whether it's hardware or whether it's hearts or biological things, whatever it is, if you're getting it back to Earth, you need a way to get it there. And right now, the Dragon is the only game in town on that. Originally, the space shuttle had the capability of bringing things back. Now, the Russian Soyuz capsule, they bring back people, but there's really not much room left for cargo. So if you want to bring back stuff, right now, the Cargo Dragon is the only choice. Now, there are a lot of programs going on with some of the smaller companies now, Momentus and some of the others, that are going to be building space tugs to move things around for collection, and then also have the landers as well. The other thing going on in low Earth orbit is Starlink. It's time for an update on that. We've talked about it before, but this is the satellite-based internet service. It's really gotten pretty big at this point. They now have over 1,600 working satellites in orbit. 1,400 of them are operational. The difference is that the remaining couple hundred, they're up in orbit, but they're not in their final orbit yet, so they can't really be used as intended. It takes a while. It takes a couple of months for them to actually get to the final orbit. Now they've got a lot more users now. They have 100,000 beta test users, and that's in 12 countries. And it started off as just the northern altitudes. Now they also have all of New Zealand. So they've expanded quite a bit on that. And they have 500,000 pre-orders. These are people that are waiting for their chance to get the service. The speeds have held up. They're about 117 megabytes on the downlink. The time delays, it takes about 48 milliseconds for a ping. That's a two-way. So it indicates like 24 seconds time delay. So that's more or less as expected. They are getting subsidies from the government for rural service, as are a lot of terrestrial cable companies. Now, one business impact that has happened, though, excuse me, is that the investment that was going to be made by the people running the geosynchronous satellites, the ones up at 22,000 miles, the big ones, the traditional ones, that's pretty much dried up for internet use. They thought they could get into that, but they realized there's no hope competing against low Earth orbit. The problem is being up so high, the time delays are way too long to be useful for most things. The power requirements for two-way transmission really get in the way. So that's out of the picture. So already there's been an impact in the market. This picture here gives you an indication of the orbits. They're all at roughly 53 degrees versus the equator. So they're all kind of, just zooming around. The idea is that almost any spot on Earth should be covered by a nearby satellite. The picture is a little bit out of orbit because earlier this year, they had also done some polar orbits, that is orbits that go over the North and South Pole. The satellites themselves look like this. They just have one solar panel sticking out on one side. Now, if you take a step back, really SpaceX is kind of two bet the company sort of projects going on right now. And bet the company means they take a lot of upfront investment before there's any revenue. But both of these really do promise major disruptions. I mean, internet service everywhere, as well as Starship. So the two things are Starlink, which is what we're talking about. And that's $5 to $10 billion in investment before there's really positive cash flow. Probably maybe 30 billion investment long term, but once you get over that initial hurdle where you're getting money out returns, then it's easy to fund the rest of the investment. Starship, which is their huge rocket ship, that's their big investment. That's about a $5 billion investment there, and that may sound like a lot to normal people, but actually you think about it, what does it cost to build a new semiconductor plant? Like the ones from Taiwan Semiconductor that we're trying to reproduce here in the U.S. You want to build one of those, it's $12 to $20 billion. So really for the cost of one semiconductor plant, we could have worldwide internet service and Starship to drastically reduce the cost of space. A little bit more about the future of Starlink. They're about to start launching the version 1.5 satellites. And these are the ones that have the laser crosslinks. And we've talked about those before too. But the idea is, if you look at how communication has to happen in this lower right-hand diagram here, if you're a user, you would talk to the satellite. And without these crosslinks between satellites, you pretty much have to communicate either directly with a ground station and onto the internet, or directly to another user just within view of that same satellite. So that's pretty limited. But that's what they had mostly so far, except for the polar satellites they've just put up as tests. But all the future ones are going to have crosslinks so that a user could talk to a user going through a crosslink, never even having to go through a ground station, or they don't have to be close to a ground station. This makes a huge difference because it means that you really can have service in all kinds of remote regions, the Arctic, the middle of oceans, or hostile countries where you don't, maybe for one reason or another, you're not going to be able to have a ground station. So this will get past all that and really speed things up. There is a secondary benefit to these satellite crosslinks, and that is that the speed of light is a lot faster in a vacuum, as it's only two-thirds of that speed in optical fiber. So you do pick up a bit on actually maybe being able to do better than terrestrial-based internet communications. Now, there have not been any Starlink launches since May 15th. That's actually had an impact on the numbers of satellite or number of launches that you've seen in the last few months. And the reason is that they're upgrading all their satellites. So they changed over their manufacturing. It took them longer than they thought. So they're getting closer to being able to start launching again. The current phase, they've been authorized for about 4,400 satellites. Remember, they only have about 1,600 now. But the big issue coming up is a revision for the generation 2, and that's about 30,000 satellites. They're going to be bigger and have more power, and they've recently proposed changes to this, and they're even going to be able to carry small payloads. And we're going to talk a little later about a company called Swarm. There's been speculation that their stuff may be involved in this, because SpaceX is buying them. The altitudes are both lower or higher. They're not all going to be the current 340 miles, and they'll be in more different orbital planes, including some sun-synchronous ones, which is interesting. Sun-synchronous means that at a given time of the day, the same satellite is over the same place. And that actually will help them for peak demands. If they know areas have peak demands, they can make sure to place more satellites overhead. So they're working those kinds of issues. The big thing coming up is that with Starship, once that's available, it's a much bigger rocket. It can take up 400 satellites at a time, as opposed to the 60 that we have now. And they also will be able to take them directly to the desired orbit, instead of going through the low orbits and then taking a few months to get to the final orbit. Why are they doing this? They're expecting 10 times the revenue they can get from the launch business. Starlink is basically the global business for space. For the most part, it is satellites when you get down to it. It's the services provided by them that generate the money, not the launch so much itself. So they're hoping for maybe $30 billion a year in revenue. And here's where Blue Origin orders are coming in again. Because Starship isn't ready yet, but they want to be able to launch on Starship, SpaceX put in 2 alternatives in their revised proposal. Based on whether or not Starship is ready, they'll fall back to Falcon 9 like they're using now. Starship is not ready. But the Blue Origin people are saying, no, that's too many proposals. You shouldn't approve this. So wrangling is occurring. There is competition. OneWeb we've talked about before. They now have 288 satellites up there. They're focused more on business customers than individuals. They're up higher, which has good and bad points. The good point is they can see, each satellite can see more of the Earth because of the curvature of the Earth. But the bad, so they don't need so many satellites. The bad side, though, is it takes more power to reach the further distance, and there's bigger time delays. The other constellations really are not very far along yet, so there's not much serious competition. Now, this does raise issues about Iridium, though, which is really the pioneer in these large satellite constellations for communications. They're not really a competitor right now. They have 2 main businesses. One of them is essentially cell phone service, except it's by satellite, some handheld devices. But the other is they do have an Internet of Things business. That is low-speed, low-power internet. For instance, for people tracking trucks and ships, they even track whales using Iridium. When a whale surfaces, there's a transmission up to the nearest satellite to tell it, location. SpaceX apparently wants a piece of this business, which they can't really address, with their larger satellites. They're actually went out and they bought a company called Swarm, and this may be the first acquisition by SpaceX. So it's pretty unusual that they actually think there's a company out there that had interesting enough technology, and I think it is. You could say this is a kind of a Honey, I Shrunk the Kids kind of a setup here, except it's a Starlink system. It looks like it in a lot of ways it's just a whole lot smaller. Right now, they have about 150 small satellites. And by small, I mean really small. We've been thinking of CubeSats, which are 3-inch cubes, as being small satellites. Well, not anymore. This is a quarter the size of a CubeSat. They weigh less than a pound at 400 grams. They look like this. This is the CEO holding one of the satellites in her hands here. And they can be launched in flat packs, a lot like the way the SpaceX has flat packs for launching their satellites. But again, these are much, much smaller. It's interesting they call them sandwich size. For some reason, they always specifically say grilled cheese sandwich. I don't know why that is. Maybe they're implying something by that. I think they just like cheese. Anyway, they have the 150 satellites up already, 40 ground stations in 2020. I didn't see a figure for this year. And they've been selling their service since February. The nature of their service is that they don't have to have a full constellation. And the reason is it's kind of down here at the bottom of the slide. It's called a store and forward network. What happens is they transmit up when there's a satellite there, and if there's no ground station to transmit it back to the ultimate user, they just wait and it holds it and transmits it. So they can't do, telephone service or video streaming or any of that. What they're doing essentially is text messages and delayed text messages, but with very low power. The devices that transmit up cost $119. It's called the Swarm Tile. There's a picture of that here. And again, you can see somebody's hand for comparison. So we're talking about something much, much smaller, than the current SpaceX, ground terminals. And it costs $36 million to get this whole thing up there. So it's, pretty much a shoestring kind of an operation. So it's aimed at the small devices, the Internet of Things. Basically things like tracking trucks. I put one of these on each truck, ships, buoys, that sort of thing. And the other big application they're saying is relaying sensor data. So in agriculture in particular, you can scatter around various sensors to monitor rainfall and temperatures and so on. And each one of them would have one of these little swarm tiles. They could transmit, say, once an hour. And, as long as you don't need the data right away, you can use that. Their data rate is only 5 kilobits a second, so it's quite small. But that's good enough for a lot of these applications. The key thing here is it's cheap. $5 a month. You get one of these tiles, you can transmit one message, which is 192 bytes, just like your SMS text messages. That's $5 a month, which means that they beat Iridium substantially. Iridium costs 4 to 20 times as much for the same kind of service. So it's a very drastic difference. So it'll be interesting to see what SpaceX really does with this. And that brings us now to the question, how many launches do you think we've had since the last meeting, which was August 7th? And as a reminder, this includes failed launches. So as long as you tried to get to orbit or beyond, we count it. So for instance, this picture that we had here, this was an Indian rocket liftoff. And it got up about 87 miles and the third stage failed. So the overall rocket was a failure, but it counts as a launch. So everybody, you should have a screen up there to say, what's your best guess on how many launches there have been since August 7th? So slightly less than a month. And just give you a few more minutes. I'm probably going to be running over here, so trying to get through it quickly. Okay, so it looks like 3 people said 10, 2 people said 9, some people said 8, a few said 6, a few said less than 5. Well, it turns out the right answer is, I'm trying to get rid of this. The right answer is 10. Now we've already talked about some of these launches, like the cargo ships to the space station. One interesting one is that the Chinese sent up a couple test satellites, possibly for setting up a network like Starlink. They may end up becoming a competitor for that. They have said they're interested in doing it, and they're starting to put the launches in place to test it out. There were a couple notable failures in here. Astra is a new space company. They've been trying to get to orbit. They've almost made it. This was their third try. They didn't quite make it. But it was probably the most dramatic failure I've seen in quite a while. You might want to check out the video on this one. One of their engines failed right away. They may have had a problem. They bumped into the launch stand or something. But anyway, one engine went out and the rocket started tipping over, and then the control system kicked in to correct it. But the problem is, with one engine out, they basically just had enough power to hover, at least with the initial weight. So it kind of just drifted sideways for a while. And then after a while, when some of the fuel got used up, then that thrust started actually overpowering the weight and it started to go up. But finally, it got up some number of miles and they blew it up. Firefly Alpha, that's their very first attempt at an orbital test flight did fail, unfortunately. Now, some other interesting things that have happened is COVID-19 is still taking a toll, directly and indirectly. The schedules for SpaceX, United Launch Alliance, and others are now at risk because there's a shortage of liquid oxygen. And the reason is that there's so much oxygen needed in hospitals right now. Now, there's other uses for liquid oxygen. It's used in some water treatment, for instance. And there have been people trying to cut back on the water treatment so that they can have that oxygen freed up for use in hospitals. And it had a kind of a secondary effect where some of the trucks that they were using to transport the liquid nitrogen, they've converted over to using oxygen instead so they can get it more to the hospitals. And now there's also have a liquid nitrogen shortage. And that did delay already a satellite launch as well. Nitrogen is used for testing, purging, and some other purposes. And then, kind of related to this somewhat indirectly, there's still the global semiconductor shortage. This is starting to delay space business as well. In particular, it's been highlighted by SpaceX as impacting their ability to build the ground terminals for Starlink. Gwen Shotwell of SpaceX was the one who also was probably really highlighting this news to everybody about the liquid oxygen shortage as well. We'll take time for a few brief questions or discussion items before we move on to introducing the main speaker.
So one thing, Greg, wasn't that Swarm, didn't they have an issue a few years back with like the FCC and launching an unlicensed
yeah, they sure did. Yeah, it's amazing they managed to recover from that. What happened is their first 4 satellites, they never got approval from anyone. They sent them up, actually, they sent them up in an Indian rocket. Then it turned out that the Indians never really asked, it was a don't ask, don't tell kind of situation. They never really asked about it. They found out and they got, they found out the FCC really complained and so now they're being much more careful about it. But they were fined $900,000 for that. And then there was a settlement where they got the $900,000 had to be paid to the government. And then a week later, they announced their new plans and put in a new proposal, and they pretty much got accepted pretty quickly. They said they corrected the problems, they apologized profusely and went on. But yeah, they were kind of the bad boys, not following the rules. Okay, well, probably should move on to introducing our main speaker, Amelia Greig. Now, she is an assistant in aerospace and mechanical engineering at University of Texas, El Paso. She leads electric propulsion and small satellite programs. And her interest obviously is in plasma technologies. That's what her PhD is in, where she got that from the Australian National University. And she's worked in several other, prominent universities, including Caltech, where she was a postdoc. Has degrees in mechanical and aerospace engineering and in theoretical physics. And she also is a NASA Innovative Advanced Concepts Fellow. What that means is she got a grant, phase 1 funding to research harvesting lunar water. She's giving a talk, in fact. NAIC is having a conference coming up fairly soon here, and she'll be speaking at that as well. So you may be hearing this first here. So her topic is talking about arc mining for in-situ resource utilization. Now, we've talked about that many times, that's really a key for sustainable expansion into space. You've got to make use of resources on places like the moon. It's just too expensive to move stuff to the moon or Mars. You really got to start living off the land. And so NASA had put up a contract for getting water, and she came back with a much more radical idea of using electric arcs and basically get multiple materials at once. You turn them into plasma, you collect them and use magnets to separate them and collect different elements like nickel and I guess silicon as well as water. So at that, I'll turn it over to Amelia.